Hello all, in this video lecture we are going to discuss about the type 2 problem of the Chebyshev filter. In this problem they have not given the direct data, so they have given the conditions here. Now from the conditions we have to extract the data, and then after that we have to simplify the problem according to the given question. Okay. Now he has given see the question here. Obtain the analog Chebyshev transfer function that satisfy the constraints 1 by root 2 less than or equal to h of j omega less than or equal to 1, and when the omega is in between 0 and 2, and h of j omega is less than or equal to 0.1 when the omega is greater than or equal to 4. And he is asking about the Chebyshev filter. So before solving it through the Chebyshev filter, we have to remember the formulas of the Chebyshev filter of the order n and the poles and the denominator function and the numerator function. So if you have thorough with this all the formulas, then it will be very easy for you for solving this question. Okay, now h of j omega in this question they have given means h of j omega is the transfer function. So what he is saying, the transfer function is in between 1 by root 2 and 1 when the omega is in between the 0 and 2. So now for solving such type of questions we have to see the graph of the low pass filter when the omega, so in the x-axis we are taking the omega and in the y-axis we are taking the h of j omega. So if the omega is in between 0 and 2, the h of j omega is in between 1 and 1 by root 2. 1 by root 2 is nothing but 0.707. So when the frequency is in between 0 and 2, the output h of j omega is between 1 and 0.7. And when the omega is greater than 4, for example, if the omega is greater than means 5, 6 and greater than 4, 5, 6 and 7, then h of omega value is 0.1. So it means that, so here the value is actually, if you compare this graph with the actual magnitude response of the low pass filter, so here this value is equal to 1 by 1 plus lambda square, and this value is equal to 1 by epsilon square. So indirectly he has given 1 by 1 plus 1 by under root 1 plus epsilon square is equal to 0.707, and 1 by 1 plus lambda square is equal to 0.5. And this is the omega. See here how we can say that this is omega p value, but the passband omega p is nothing but passband frequency. So passband frequency means the frequency at which we are getting the maximum output. So at 2 only we are getting the maximum output, right? So that's why this is omega p, and at omega s is the stop band frequency. Here we are not getting the output. The output we are getting is only 10%. So we are considering it as a omega s. So omega p is equal to 2 and omega s is equal to 4. So this is the data we got. So this is the data we got. So 1 by 1 plus epsilon square is equal to 1 by root 2, 1 by under root 1 plus lambda square is equal to 0.1, omega p equal to 2 and omega s is equal to 4. So from this, if you calculate, if you evaluate epsilon is equal to 1 you may get, and lambda is equal to 9.95 you got. So for solving such problems, only extracting the data is very important. After that we all know the formulas. So for the order n greater than or equal to cos h inverse of lambda by e. So cos h inverse of lambda by e, lambda means 9.95 by e means 1 we have substituted here. The same way in the denominator cos h inverse of omega s by omega p, omega s is equal to 4, omega p is equal to 2. So if you solve this with the calculator, you will get the values 2.269. And we know if you got any fractional number, we have to round off it to the next integer value. So the next integer value of 2.269 is equal to 3. So we are rounding the order equal to 3. So order value n is equal to 3 we got. Next target is we have to find out the poles. So in case of Chebyshev filter, for finding the poles we need to have the 4 values. One is a and b values, and one is epsilon value, and one is mu value. If you have the epsilon value, then you can calculate the mu value. If you have the mu value, then we can easily calculate the a and b value. That's why first of all find out the mu value. Mu value is equal to epsilon power minus 1 plus under root 1 by epsilon power minus 2. So epsilon already we calculated here. So you substitute this 1 by 1 plus root 2 you will get. So the answer is 2.414. You got the mu value. So you got mu value, then we will calculate the A and B values. The A value is A is equal to omega p into mu power 1 by n minus mu power minus 1 by n by 2, where n is equal to order. So you substitute, and omega p is the passband frequency. We have 2. So we have, say simply I'm substituting the omega p value and the mu value in the formula. So I got this 2 equal to 2 of 2.414 whole power 1 by 2, 1 by n means 1 by 2 minus 2.414 whole power of minus 1 by 2 by 2. If you solve this sum with the calc C, you will get 0.596. Similarly, you calculate the B value also. So if you calculate this B value, you got this value 2.087. The difference between the A and B is, here we got plus value. The rest of the thing is same. Mu power 1 by n plus mu power minus 1 by 2. Here we have minus here. And now calculation of poles. The poles is including Sk is equal to, the formula for calculating poles is Sk is equal to A sin pi k plus A cos pk plus j into B sin pk. So first of all, we have calculated A and B values. Then it is time to calculate the pi k. The pi k formula is pi by 2 plus 2k minus 1 into pi by 2n, where the k value is rolling from 0 to n. Here the order n value is equal to 3. So we will get the k values are 1, 2 and 3. So for each and every instance, we will assume the k value as 1. So we got pi 1. So pi by 2 plus 2k means 1, 2 of 1 minus 1 into pi by 2 into 3. So I got the 2 pi by 3. And similarly, for pi by 2, I got the pi value, and pi 3, I got the 4 pi by 3. The calculation is written here. So after having pi 1, pi 2, pi 3, now it is time to calculate the poles. The poles formula is equal to A cos pi k plus j b into sin pk. You have A value, you have B value, and you have pi k values. Pi k value, if you want to calculate S1, when k is equal to 1, you substitute A cos pi 1 plus jb into sin pi 1. If you are calculating S2, then A cos pi 2 plus jb into pi 2. If you are calculating S3, A cos pi k plus j into b sin pi k. Now see this, I have calculated S1, S2 and S3. S1 as omega p value is 0.596 into cos pi 1 plus j into b value. A value is equal to 0.59 pi 1 plus j sin pi 1. So we, like this, we have calculated S1, S2, S3. Then after calculating the S1, S2, S3, then the denominator polynomial we have to calculate. The denominator polynomial is dfs is equal to s minus s1 into s minus s2 into s minus s3. Actually this formula continues for s minus sn also, but here we have the n value 3, so we have only three poles, s1, s2 and s3. So I am substituting s1 value. I got s minus s1 value is minus 0.298 minus 0.298 plus j into 1.807. The same value I am substituting here. S minus 0.298 plus j into 1.807, and S minus S2 value also I have substituted. S2 value is 0.596 minus 0.596 I have substituted here, and S3 value also I have substituted here. After doing the substitutions, then you have to simplify this. This depends upon your how fast your mathematical calculation is. So simply I have simplified this. I got ds value is this. Okay, now the next term is calculating the numerator polynomial value. So we don't have any separate numerator value. So you have to substitute s is equal to 0 in the d of s. So you will get the n of s. So after substituting s is equal to 0, the resultant you have to substitute, you have to divide by 1 plus epsilon square when the n value is even, but here the n value is 3, so it is the odd number. So you don't need to divide the result by 1 plus epsilon square. Simply substitute s is equal to 0 in the denominator, then keep the result as a n of s. So I have done the same thing. So in this equation in this equation substitute s is equal to 0. This at this place is s is equal to 0, and at this place s is equal to 0, and do the calculation using the calculators. You got the value is 2. So the next thing is finding the transfer function. The transfer function h of s is equal to n of s by d of s. So n of s 2 you got, d of s is this value. So after that I'm simply expanding this function as a single function. So this is s plus 2.298 whole square. I'm expanding this. You will get this function. So this is the h of. Once your h of s is obtained, it means that your filter has been designed. Thank you for watching my channel and video today.